So in part C, we're given a solid line that represents the standing wave at time t, and a dotted line represents the standing wave an instant later. We're told the dot is in equilibrium position. The dot is the equilibrium position of the particle of P in the pipe, and the arrow pointing, well, the upwards pointing arrow shows displacement to the right, and the downwards pointing arrow shows displacements to the left. So what we need to think about here is that since we have sound waves, these are longitudinal waves, they are moving left and right. So these particles are not oscillating up and down. In fact, they are oscillating left and right. That's why we have this convention here. So we're asked in the diagram to draw a dot to indicate the approximate position of P at time t. So what we see is that we have this dotted line, which is lower down than the solid line. And what that means is if it's lower down, it means it's more to the left, because downward displacement means displacement to the left. Therefore, the particle has to be more to the left. And in part C2, we need to draw an arrow to indicate the velocity of P at time t. So what we need to see here is that the amplitude is not at the maximum yet, so there's still more distance, so it can still go further to the left, which means it is going to go further to the left, and therefore it will have a velocity pointing to the left as well.